Canny College is dedicated to empowering individuals to excel in their truck and transport mechanic trade through top-notch preparation courses for the 310T Red Seal Trade Licensing Exam. Our online course is comprehensive and designed to equip you with the skills, knowledge, and confidence needed to pass the demanding truck and transport mechanic trade license exam and earn your 310T Certificate of Qualification. We are your trusted pathway to success in the Canadian Red Seal Trades License Exam, a crucial milestone on your journey to a rewarding career in the skilled trades industry. Aspiring professionals seeking a Canadian Red Seal trade license can rely on our institution's expertise. Canny College offers comprehensive online exam preparation courses for various skilled trades. It uses an innovative learning approach and a commitment to excellence to equip students with the essential skills and expertise required to succeed in their chosen trades. Visit our website at www.cannycollege.com for more details. Please note that the practice questions provided here demonstrate the structure and phrasing of Red Seal examination questions. They are for study purposes only and do not result in certification or reflect actual performance on the examination. Question 1. An ammeter is connected to check an electrical circuit. What is done? A. Connect in series with the load. B. Connect in parallel with the load. C. Connect across the voltage supply. D. Connect in series parallel with the load. The correct answer is A. Connect in series with the load. Here are 4 reasons why the ammeter should be connected in series with the load. 1. Current measurement. Connecting the ammeter in series with the load allows for the measurement of the current flowing through the circuit. Placing the ammeter in series creates a single path for the current to pass through, enabling an accurate measurement of the current drawn by the load. 2. Circuit integrity. By connecting the ammeter in series, the circuit remains intact, and the current is forced to flow through the ammeter to provide an accurate reading. This setup preserves the circuit's functionality while enabling the measurement of current. 3. Accuracy and precision. Placing the ammeter in series with the load ensures that the ammeter measures the precise amount of current passing through the circuit without introducing resistance or altering the circuit characteristics. 4. Safety. Connecting the ammeter in series with the load allows for safe and reliable current measurement without the risk of damaging the ammeter or the circuit components. This method helps ensure accurate readings while maintaining the safety of the equipment and the user. In summary, connecting the ammeter in series with the load is essential for accurately measuring current flow in an electrical circuit, while maintaining circuit integrity, ensuring accuracy, and promoting safety during the testing process. Question 2. A grinding noise is heard when shifting down from a high range to a low range in a twin countershaft transmission. What is the problem? A. Faulty transmission slave valve. B. Faulty transmission range selector valve. C. Worn sliding clutch on splitter in auxiliary section. D. Worn synchronizer assembly in the auxiliary section. The correct answer is D. Worn synchronizer assembly in the auxiliary section. When a grinding noise is heard when shifting down from a high range to a low range in a twin countershaft transmission, the issue may be due to a worn synchronizer assembly in the auxiliary section. Here are some reasons why this could be the problem. 1. Synchronizer function. The synchronizer assembly is responsible for equalizing the speed of the gear and the main shaft to enable smooth shifting between gears. If the synchronizer assembly is worn, it may not be able to synchronize the gear speeds properly, leading to grinding noises during shifting. 2. Gear engagement. A worn synchronizer assembly can result in difficulty engaging gears, particularly when shifting down from a high range to a low range. This can cause grinding as the gears fail to mesh smoothly during the shifting process. 3. Misalignment. Worn synchronizer components can lead to misalignment during gear engagement, causing the gears to clash rather than mesh seamlessly. This misalignment can result in the grinding noise heard when shifting down in the transmission. 4. Wear and tear. Over time, the synchronizer assembly may experience wear and tear due to normal use, leading to decreased effectiveness in synchronizing gear speeds. This wear can result in issues such as grinding during gear shifts, particularly when moving between high and low ranges. In summary, a worn synchronizer assembly in the auxiliary section of a twin countershaft transmission can lead to grinding noises when shifting gears, especially when moving from a high range to a low range due to synchronization issues. Question 3. Shortly after an injector has been replaced, engine oil is found to be diluted with fuel. What is done? A. Replace the fuel regulator valve, then road test. B. Replace the fuel pump and the filter, then road test. E. Pressure test the fuel gallery, then check for leaks. D. Pressure test the fuel transfer pump, then look for leaks. The correct answer is C. Pressure test the fuel gallery, then check for leaks. Here are 4 reasons why pressure testing the fuel gallery and checking for leaks is the appropriate step in this situation. 1. Leak detection. Pressure testing. The fuel gallery helps identify any leaks in the system that may be causing fuel to mix with the engine oil. By pressurizing the system, you can pinpoint the source of the leak and address it accordingly. 2. Injector seal. A common issue after an injector replacement is a faulty injector seal that could be allowing fuel to leak into the engine oil. Pressure testing the fuel gallery can help determine if the new injector is properly sealed and functioning as intended. 3. Prevent further contamination. Diluted engine oil can lead to decreased lubrication properties and potential engine damage. By identifying and fixing the source of the fuel leak, you can prevent further contamination of the oil and ensure the engine operates correctly. 4. Comprehensive examination. Pressure testing the fuel gallery allows for a thorough examination of the fuel system integrity, including seals, connections, and injectors. This diagnostic approach helps identify and resolve any issues contributing to fuel leakage into the engine oil. In summary, pressure testing the fuel gallery and checking for leaks is essential in diagnosing and resolving the problem of fuel dilution in the engine oil after an injector replacement. This step helps ensure proper engine function and prevents potential damage due to contaminated oil. Question 4. What is the final step before returning a vehicle to service? A. Run the vehicle to operating temperature. B. Clear active fault codes. C. Clear historic fault codes. D. Update vehicle service records. The correct answer is D. Update vehicle service records. Here are 4 reasons why updating vehicle service records is crucial before the vehicle is returned to service. 1. Maintenance history. Updating the vehicle service records ensures that accurate and up-to-date maintenance information is documented. This history is valuable for tracking previous services, repairs, and inspections, which can help in diagnosing future issues and planning maintenance schedules. 2. Compliance and documentation. Proper service records are essential for compliance with warranty requirements, maintenance schedules, and regulatory standards. Keeping detailed records helps to demonstrate that the vehicle has been properly maintained and serviced according to manufacturer specifications. 3. Diagnostic reference. Accurate service records provide valuable information for future diagnostic purposes. Mechanics and technicians can refer to the service history to track any recurring issues, identify trends, and make more informed decisions about repairs and maintenance. 4. Resale value. Well-documented service records can enhance the resale value of a vehicle. A complete maintenance history provides reassurance to potential buyers regarding the vehicle's condition and maintenance, potentially leading to a higher resale value and smoother transaction. In summary, updating the vehicle service records is a critical final step before returning a vehicle to service, ensuring proper documentation, compliance, diagnostic reference, and potentially increasing the vehicle's resale value. Question 5. An engine experienced a major connecting rod bearing failure. What is done to the oil cooler during the engine overhaul? A. Replace core assembly. B. Steam clean and air dry. E. Reverse flush with solvent. D. Clean thoroughly with solvent and blow dry. The correct answer is A. Replace core assembly. Here are 4 reasons why it is essential to replace the oil cooler core assembly during the engine overhaul. 1. Contamination removal. A major engine failure, such as a connecting rod bearing failure, can result in severe contamination of the oil cooler with metal particles, debris, and sludge. Replacing the oil cooler core assembly ensures that any contaminants are completely removed from the cooling system. 2. Preventing recirculation. If the oil cooler core assembly is not replaced, there is a risk of recirculating contaminants through the engine system, potentially leading to future problems, reduced engine performance, and accelerated wear on internal components. 3. Performance and efficiency. Installing a new oil cooler core assembly ensures optimal performance and efficiency of the engine cooling system. A new core assembly provides proper heat exchange, and ensures that the engine operates within the optimal temperature range, reducing the risk of overheating. 4. Long-term reliability. By replacing the oil cooler core assembly, you help restore the engine's reliability and longevity. A new core assembly eliminates the risk of residual contamination, causing issues in the future, promoting the engine's overall durability and performance. In summary, replacing the oil cooler core assembly during an engine overhaul, especially after a major engine failure, is crucial for removing contaminants, preventing recirculation, maintaining performance and efficiency, and ensuring the long-term reliability of the engine cooling system. Question 6. When a starter is dismantled, it is observed that the armature has made contact with the field windings. What is the cause? A. Open armature winding. B. Open field winding. C. Worn commutator bar. D. Worn armature bushings. The correct answer is D. Worn armature bushings. Here are 4 reasons why worn armature bushings could lead to such contact. 1. Misalignment. Worn armature bushings can lead to misalignment of the armature within the starter housing, causing it to come into contact with the field windings. This misalignment can result in interference between the components and may damage the windings. 2. Excessive play. Over time, worn armature bushings can create excessive play or movement in the armature shaft. This increased play can allow the armature to shift out of position, potentially causing it to contact the field windings during operation or disassembly. 3. Vibration and wear. Worn armature bushings may no longer provide the necessary support and stability for the armature shaft, leading to increased vibrations and movement. These vibrations can contribute to the armature coming into contact with the field windings, especially under the stress of starting operations. 4. Friction and rubbing. Worn armature bushings may not properly center and support the armature shaft, potentially causing it to rub against the field windings during operation. This friction can result in damage to the windings and affect the overall performance of the starter motor. In summary, worn armature bushings can lead to misalignment, excessive play, increased vibrations, and potential contact between the armature and field windings in a starter motor. Identifying and replacing the worn bushings is crucial to prevent further damage and ensure the proper functioning of the starter system. Question 7. What is observed during a road test to verify low power on a diesel engine? A. Boost and fuel pressures. B. Boost and crankcase pressures. C. Fuel pressure and exhaust temperature. D. Fuel temperature and exhaust back pressure. The correct answer is A. Boost and fuel pressures. Here are 4 reasons why monitoring boost and fuel pressures is crucial. 1. Boost pressure. Boost pressure, often measured by a boost gauge, provides insight into the turbocharger's performance and efficiency. Low boost pressure can indicate issues such as turbocharger malfunctions, leaks in the intake system, or restricted airflow affecting engine power output. 2. Fuel pressure. Monitoring fuel pressure helps assess the fuel delivery system's functionality and the engine's ability to receive the required fuel volume and combustion pressure. Low fuel pressure can lead to inadequate fuel delivery, resulting in reduced power output and engine performance. 3. Relationship between boost and fuel pressures. By observing both boost and fuel pressures during a road test, technicians can evaluate the correlation between turbocharger performance and fuel delivery. Discrepancies between boost and fuel pressures can help pinpoint specific areas of concern affecting the engine's power production. 4. Diagnostic insight. Analyzing boost and fuel pressures in real-world driving conditions allows for a comprehensive assessment of the engine's operation and can aid in diagnosing low-power issues accurately. Data obtained from monitoring these pressures can provide valuable insights for troubleshooting and resolving performance-related concerns. In summary, monitoring boost and fuel pressures during a road test is instrumental in diagnosing low-power issues in a diesel engine. These parameters offer valuable diagnostic information to pinpoint the root cause of performance deficits and support effective troubleshooting and repair procedures. Question 8. An engine is losing coolant, but there is no external leakage. What is done? A. Pressurize the oil system, then check for oil in the cooling system. B. Pressurize the fuel system, then check for signs of fuel in the coolant. C. Run the engine to operating temperature, then check the exhaust manifold for poor cylinder performance with a heat thermometer. D. Drain the oil, pressurize the cooling system, then check for coolant leaks at the drain plug. The correct answer is D. Drain the oil, pressurize the cooling system, then check for coolant leaks at the drain plug. Here are 4 reasons why. 1. Draining the oil allows for a clear inspection of the oil for any signs of coolant contamination. Coolant leaks into the oil system can often be detected by inspecting the drained oil. 2. Pressurizing the cooling system helps to identify any leaks that may not be visible under normal conditions. This can help locate the source of the coolant loss. 3. Checking for coolant leaks. Specifically at the drain plug is important because it is a common location for coolant leaks to occur, especially if there is a problem with the engine's internal cooling system. 4. By isolating and examining the cooling system separately from other systems like the oil or fuel system, it becomes easier to pinpoint the exact location and cause of the coolant loss. Question 9. The oil pressure fluctuates on a diesel engine. What is done? A. Check engine oil level, then test engine oil sensor. B. Check engine oil level, then test oil pump and inlet assembly. C. Check engine oil level, then send oil sample for analysis. D. Check engine oil level, then manually check oil pressure. The correct answer is D. Check engine oil level, then manually check oil pressure. Here are 4 reasons why. 1. Checking the engine oil level is important because low oil levels can lead to insufficient oil pressure, causing fluctuations. By ensuring that the engine has an adequate amount of oil, it helps maintain proper lubrication and pressure. 2. Manually checking the oil pressure allows for a direct assessment of the pressure readings, which can help determine if there are any issues with the oil pressure sensor or gauge inaccuracies. This method provides a more immediate and accurate evaluation of the oil pressure situation. 3. Fluctuating oil pressure could indicate potential problems with the oil pump or inlet assembly. By manually checking the oil pressure, helps in identifying whether the fluctuations are due to issues with the oil pump or inlet assembly that may require further inspection or maintenance. 4. Regularly monitoring and manually checking the oil pressure can help prevent potential engine damage or failures. Detecting fluctuations early on and addressing any underlying issues promptly can help maintain the engine's performance and extend its overall longevity. Question 10. A vehicle is difficult to get out of gear. What is the cause? A. Warped clutch discs. B. Worn pilot bearing. C. Out of adjustment clutch brake. D. Insufficient clutch linkage free play. The correct answer is A. Warped clutch discs. Here are 4 reasons why. 1. Warped clutch discs can lead to irregular contact between the clutch components, which can make it difficult to disengage the clutch when trying to shift gears. This can result in difficulty getting the vehicle out of gear. 2. Warped clutch discs may cause uneven wear on the clutch components, leading to a loss of smooth engagement and disengagement of the clutch. As a result, shifting gears can become challenging and require more effort. 3. The warped clutch discs may not fully release the pressure on the clutch assembly when the clutch pedal is depressed, causing the clutch to drag. This can result in resistance when trying to shift gears and difficulty in getting the vehicle out of gear. 4. Warped clutch discs can also cause clutch slippage or grabbing issues, further complicating the process of getting the vehicle out of gear. These issues can affect the overall performance of the clutch system and make shifting gears more problematic.